supervisions. So recently we have received one AICTE Idea Lab also. Okay. So first of all, I extend my sincere thanks to the management, principal, HODs, and Professor Naresh Mallireddy, who invited me for the talk of AICTE PRERANA session. Okay. So I'll thank all the staff members of Hindustan College of Engineering and Technology for providing an opportunity. Thank you, sir. So actually, as per the GATE syllabus, we have 4 sessions. You people are much aware of that. The first session, it is completely from engineering mathematics, okay? And second session, applied mechanics and design concept. It is composed of some related problem like beam structures, springs. இதெல்லாமே வந்து உங்களுக்கு பார்த்தீங்கன்னா செகண்ட் யூனிட்ல கவர் ஆகும். The entire syllabus should be engineering mechanics based one. Third session, it's fully fluid mechanics and thermal science. Okay. And last module we have material manufacturing and industrial engineering. So this concept, I'm going to share my knowledge, especially in the area of phase diagrams and heat treatment. Okay. So this is the particular topic for your GATE syllabus, that is called engineering materials, structure, properties of engineering material, phase diagram, heat treatment, stress strain diagram for engineering materials. So I'm going to handle only a 2 concept regarding phase diagrams and heat treatment. Okay. So this is our clear objective of this today's session. Okay. I'm going to share about the engineering material knowledge, especially in the field of phase diagram and heat treatment. Is it clear? Okay. So what is meant by phase diagram? So normally we have some data should be represented to identify the structure. So in the phase diagram, it is nothing but a graphical representation. Graphical representation, so now we need 2 axes, X and Y. Okay. So in X axis, we are going to represent the weight percentages of carbon. In Y axis, we have to keep the variable of temperature. Okay. So in this phase diagram, these different conditions of temperature and pressure, what is the composition, what type of phases are going to exit. Okay. So this particular information is needed for the engineer and scientist to develop a new material. So without the knowledge of phase diagram, we can't able to define the particular property and application. So it is very essential. So once again, I will give the definition of phase diagram is nothing but it is a graphical plots which are devised to show the relationship between various phases that appear within the system under equilibrium. Okay. Here in various phases ன்றப்ப நமக்கு வந்து பார்த்தா அப்படி ஜெனரலா நீங்க 3 ஸ்டேட் சொல்றீங்க, liquid, solid and gas. Okay. But here in the engineering metallurgy aspect, we are going to show some of the phases, maybe in the form of ferrite, austenite, cementite. Anyway, I'm going to share this content in the next couple of slides. So before that, we have some knowledge about the phases. Okay. And another important aspect in the phase diagram is you can able to identify the temperature and composition map, which indicate what phases present at a given temperature. Composition in the sense you have add some carbon element in the iron. So it is called composition. Not only that, some cases we have add some of the alloy element also, like chromium, nickel. So these materials are helps to get important mechanical property, especially corrosion, wear, high temperature resistance. So what is the particular informations we have to collect it from the phase diagram is the composition, temperature, microstructure studies, solidification. These are the valuable informations we can collect from the phase diagram. So as a student, you please aware of that. It have 2 axes. In x-axis, you are going to present the percentage of carbon. Y-axis, temperature. Temperature or degree padina centigrade la use panna porom. Okay, fine. So this is the particular information what I just suggested. The 4 information is very valuable. Even last year also 1 questions are framed from this phase diagram only. Okay. Anyway, I will share some of the questions at the end of the session. So before that, you have to get some knowledge. Okay, what are the information we have to collect from the phase diagram? The first one, to show what phases are present at different compositions and temperature under equilibrium condition. Now already highlight பண்ணதா phases in the sense அது வந்து liquid or solid. Then some allotropy forms of ions also present. Okay, that is called phases. Different phases you can able to predict or identify. Second thing, it clearly indicates the equilibrium of solid solubility of one element in another element. This is very, very important. So before going to touch the solid solubility, you have to recall or revise the concept of solid solution. So you people are studied already in your engineering metallurgy subject. Solid solution is nothing but two solids are completely soluble with each other. It having homogeneous structure. Is it right? Okay. So we studied two types of solid solution. Is it correct? One, substitutional solid solution, and another one will be interstitial solid solution, because this knowledge is very, very essential to identify the solute element in the solvent. Okay. So what is meant by solid solution? It needs two material or two phase. One, solvent, it having a maximum content. Second, solute, it having very less weight percentage. Example, brass. Brass is a combination of copper and zinc. Suppose copper having 64%, because it is having more weightage, so we can call it as solvent material. Remaining 36% are solute. Solute means only small content, so we can call it is a substitutional solid solution. So we have to replace the copper by adding some solute of zinc. So once if it is combined, we have to produce the brass material. So many engineering materials are made with the help of solid solution only. Example, steel is an interstitial solid solution, because we are going to add some solute in the form of carbon in between of iron. Okay, so it's just a revised concept only. You have to aware of solid solution. Okay, so solid solution means two solids are completely soluble with each other and having homogeneous structure. இது நீங்க தெரிஞ்சா போதும். Maximum content க்கு பேரு solvent, minimum content க்கு பேரு solute. ஓகேவா? You got the point? Maximum material எதுவோ அதை நீங்க solvent சொல்லலாம், minimum material எதுவோ அதை நீங்க solute சொல்லலாம். ஓகே, ஸோ ரெண்டு டைப் நான் சொல்லிட்டேன். ஒன்று சப்ஸ்டியூஷனல், இன்னொன்று வந்து இன்டர்ஸ்டிஷனல் சொல்லியிருக்கேன். சப்ஸ்டியூஷனல் வந்து நம்ம ரெண்டா பிரிக்கலாம். அகைன் we have two classification of substitutional solid solution. One, ordered substitutional solid solution. Second one, disordered. Ordered means the replacement of solvent in the regular pattern. Okay, disordered means randomly replacement should be happen. So these are the two types of solid solution. Interstitial means there is no replacement. Only thing is the small amount of solute atom should be added in between of solvent material. The good example is steel, because carbon should be a small percentage. Example, 0.25% of carbon should be added in between the solvent of iron. So this is a very good knowledge of solid solution, is very essential. You have some questions regarding the concept of solid solution. Okay, so the second information is to indicate or to represent the equilibrium of solid solubility of one element in the other element. So with this information we can identify the percentage of element in materials. Okay, the third information is to indicate the temperature range over which solidification of material occur. Solidification is nothing but ஒரு மெட்டீரியல் ஹீட் பண்ணிட்டு கூல் பண்ணீங்க அப்படின்னா it will produce the second phase. So example, ice cube, initially it having liquid phase. So after freezing of a couple of hours, the entire liquid should be transformed to solid. So solid phases is nothing but the cooling curves, and the cooling curves நம்ம already work out பண்ணிருப்பீங்க maybe. So P plus F equal to C plus 2. So P stands for phases, F degree of freedom, C number of component, and variables may be temperature or pressure. So this knowledge is very essential for understanding the solidification process. So this phase diagram helps to identify the range of temperature. And the last information is to indicate the temperature at which different phase start to melt. So phases already so liquid or solid or where phases on the modification or changes temperature identify. So these are the 4 essential information needed for the phase diagram. Okay, so these are the particular knowledge is essential. So in GATE 2020, one question is framed from the phase diagram. Okay, so at the end I will ask the question to you. So please understand this 4 information. Okay, so I will move to the next slide. Okay, so next, allotropy forms of different material is very essential to understand the phase diagram. Okay, but the first allotropy form of metal is alpha ion. The name is called ferrite. This ferrite symbol will be alpha. The structure of the metal is body centered cubic structure. Simply we can call it BCC, body centered cubic structure, and the maximum stable temperature is 908 degrees centigrade. So you have to understand the symbol alpha is a representation of ferrite material. Anyway, I will show the microstructure. So before going to that, you have to understand the structure and stable temperature. Is it right? Second material is gamma ion. Gamma stands for austenite. It is very, very essential material for all the material science related subject, because in the next concept heat treatment also you're going to study about the austenite material. Okay, so first one alpha, second one austenite. The symbol is gamma. The structure is face centered cubic structure, and the maximum stable temperature should be in the range of 908 degrees centigrade to 1388 degrees centigrade. So this is the maximum stable temperature. Okay, 1388 degrees is the austenite range. Next, last one is delta ion. Again, delta ion is the form of BCC. So we can call it is a delta ferrite. Sometimes we can say it is a delta ferrite because once again the face center cubic structure is changed or modified to BCC. So delta ferrite in resume pathinga is also almost similar to ferrite form. But the only thing is we have to change the symbol delta. So the maximum temperature for delta is 1535 degree centigrade. After that, all the solids are converted to liquid state. So this is the maximum stable temperature for different forms of material: alpha, ferrite, gamma, austenite, delta, ferrite. Okay. So any doubt up to this particular slide from student side? Shall I move for the next one? From student side, any doubt regarding this thing? No response. பசங்க இருக்கீங்களாப்பா சஞ்சய்? One student யாரும் ஆன்சர் பண்ண மாட்டீங்க. From student side, according Sanjay, any other student? Prabhu sir? Okay, shall I continue? Enough answer பண்ண மாட்டீங்க students. So any faculty from Hindustan, sir? Please say yes or no. Anyone, any faculty members or student? So So any clarification up to this slide from students' point of view? Shall I continue, sir? Please say yes or no. Anyone? Okay, sir, continue. Okay. So only chat done, huh? Okay, sir, continue. Thank you. So, so no clarification up to this one. Okay, fine. So alpha, austenite, and delta. Okay, so these are the three material having different structures and temperature. So next we move for the important micro constituent of iron carbon alloys. Means alloy means having more than one or two element is called alloys. Okay, so this particular information is needed to understand the iron carbon diagram. Okay, so any microstructural modification we have some knowledge regarding the micro constituent. So in iron carbon diagram these are very essential. First one being ferrite, austenite, cementite, pearlite, ladybirite, martensite, trossite, sorbite, binite. So these are the particular. So the yellow color highlighted some material. Okay, some phases are very essential because these phases are you are going to use frequently. Okay, ferrite, austenite, cementite, pearlite, martensite, and binite. These six. Okay, so these six phases are frequently you're going to use. So ferrite, alpha, austenite, gamma, cementite, Fe3, pearlite is a mixture of ferrite and cementite. Okay, so martensite, if austenite is cooled slowly, we will get martensite structure. Okay, so anyway, we will have some discussion about various phases. Sorry. So the first particular phases of your iron carbon diagram is ferrite. So ferrite is a solid solution based on alpha iron having body centered cubic structure. Okay, so it is nothing but interstitial solid solution of carbon in iron. So iron is a interstitial solid solution of carbon. Its structure is BCC, body centered cubic structure, and symbol is alpha. Third, the maximum percentage of carbon in iron is 0.025% and 727 degrees the temperature. Okay, so while the maximum solubility means limit for any iron is 0.08%. So what is the unique properties of ferrite is it is having soft, ductile, and highly magnetic property. So these are the properties for the ferrite material. Okay, so you have to keep three important things. Ferrite symbol will be alpha, structure is BCC. Okay, maximum percentage of carbon is 0.025 and properties are soft, very soft, ductile, and highly magnetic. Okay, so this is a very particular material. Second one is austenite. So austenite is once again is a primary solid solution of gamma iron having face centered structure. It is also come under interstitial solid solution. Once again, iron, it is maximum solvent material, solute carbon. So in between iron you are going to add some percentage of carbon. So we can call it as interstitial solid solution. So maximum percentage of carbon in austenite is 28% and stable temperature is 1140 degrees. So previously I pointed out some 1905 to 114. So this is a maximum stable temperature, and the important properties for austenite material is soft, tough, and very highly ductile. So it is a toughness will be increased by adding more weight percentage of carbon. Okay, so this is a particular information is very essential or needed for understanding the concept. Okay, so austenite, gamma, maximum weight percentage of carbon is 2%. Property soft, tough and highly ductile. Okay. And third important microstructure is cementite. So cementite, when we heard about the term cementite, is more percentage of carbon, that is called carbide. So the symbol we can prefer for cementite is Fe3. So Fe stands for iron, C stands for carbon. So more carbons are involved in the cementite structure. So once if you add more weight percentage of carbon, ultimately the properties are changed from ductile to brittle. So that is most of the cases cast irons are failed due to brittle nature because of more weight percentage of carbon. So when we speak about the cementite, it is a very hard, brittle, intermetallic compound of iron with 6.6 percentage of carbon. So maximum percentage of carbon is involved in the cementite. And look at the properties, it having hardness and brittleness. Okay, so what I pointed out that cast iron is come under this category. So cast iron involved more weight percentage of carbon from 2 to 6.67 percentage. Okay, so it is magnetic below 250. Some property like magnetic also involved, but these are the very essential, hard, brittle. Anyway, I will show the structure, and very important microstructure is pearlite. So this phase having a mixture of ferrite and cementite. It is a combination of ferrite metal alpha and cementite is Fe3. So 87.5% in the form of ferrite, remaining 12.5% in the form of cementite. So pearlite is nothing but mixture of ferrite and cementite. So how the pearlites are produced? It is nothing but when austenite materials are composed to cooling. Okay, when austenite is decomposed during cooling process, it has to produce the pearlite structure. So the maximum percentage of carbon is 0.8 percentage. So it looks like a thin layer of lamellar of structure of ferrite and cementite. Anyway, I will show the microstructure, you can understand. So my suggestion is you have to remind these two name. When you heard about the pearlite, is nothing but it is a mixture of ferrite and cementite. இந்த ரெண்டு வார்த்தை ஞாபகம் வச்சுக்கணும். Pearlite அப்படினாலே ferrite, combination of ferrite and cementite. So please keep in mind, because I'm going to repeatedly use this word pearlite. It is a transmission from austenite to formation of ferrite and cementite. So how it looks, it's like a thin layer of ferrite and cementite. I will show the picture. So what is the property it having is relatively strong, hard and ductile. So these are the very essential properties for pearlite material. Very strong, hard and ductile structure. Okay. So this is the ladubrate, one form of structure. So mostly the pig iron. Pig iron is more percentage of carbon. The ladubrate will be formed. It is also the mixture of austenite, gamma and cementite. The maximum content of carbon is 4.3. So previous 0.8 only, but in ladubrate it having 4.3 percentage of carbon. So mostly the ladubrate are formed under pig iron only. So this is the one of the good example for ladubrate structure is only pig iron. And one more important structure is Martensite. It is very important phases because most of the hard materials, that is hardness, are obtained under this microstructure only. Okay, so Martensite is nothing but it is a super saturated solid solution of carbon in alpha iron. So when it formed means when a steel is very rapidly cooled from austenite state to, it will produce pearlite, then binite, last one will be Martensite. So ஒரு ஸ்டீலை நீங்க சடனா கூல் பண்ணீங்க அப்படின்னா உங்களுக்கு Martensite ஸ்ட்ரக்சர் வந்து கிடைக்கும். That is very essential. So anyway, I will show the picture. You can able to understand how the microstructure modifications happen from austenite state to Martensite. So Martensite state or structure pathina, it's like a needle like structures. Okay, so it's like a sharp needles are produced because we have done some rapid cooling process. So what are the unique properties of Martensite material? It is very hard, more ductile and low ductility property. So we have to fail to achieve the ductile property. Ductile means deformation. So we have to lose the deformation property because of carbon only. Okay. So hardness is increased as a result material changes from ductile property to brittle property. Okay, so anyway, they have, the essential thing is hardness is improved. Okay, so this is one of the important microstructure Martensite. The remaining things are Trossite and Vinite Swarbite. So what is a Trossite? Trossite is nothing but it's a mixture of radial lamb of ferrite and cemented. Once again, it is a combination of ferrite and cemented, almost pearlite Maria, but only the microstructural thing will be changed. Okay, some fine degree of changes. Look at that thing is because pearlite நாலுமே ferrite and cementite தான் சேர்ந்துருக்கும். ரெண்டுமே changes பண்ணதான் pearlite. Trossite-க்கும் pearlite-க்கு என்ன சார் டிஃபரன்ஸ் கேட்டீங்கன்னா only micro level தான். That is nothing degree of fineness. Then Swarbite is one of the micro consists of ferrite and finely divided cementite. It is produced on tempering of martensite about 450 degrees centigrade. So Swarbite it is once again a combination of ferrite and cementite only. So almost all the cases we have ferrite and cementite. Okay, last one will be Vinite. It's nothing but it is a decomposition product of austenite material. So austenite materials நீங்க cool பண்ணீங்க அப்படின்னா you will get a form of ferrite and carbide. So Vinite is a decomposition product of austenite consisting of an aggregate of ferrite and carbide, alpha and carbides, Fe3 ரெண்டுமே சேர்ந்தது தான். So once again we have made two classification for the Vinite material. One will be upper Vinite and another one will be lower Vinite. In the upper Vinite means the Vinite is obtained by the transformation of pure at higher temperature. So இது பாத்தீங்க அப்படின்னா ஒரு around 600 to 650 degree. This particular temperature, the austenite is changed to pearlite. The structure is look like upper Vinite. In lower Vinite it is a low temperature around 300 to 400. In this particular temperature, the transformation happened. So we can call it as lower Vinite. So upper Vinite or lower Vinite. Please remember these two technical terms: higher temperature of pearlite, lower temperature of pearlite. Because this may ask some question, the MCQ type. Okay. So these are the particular microstructure of different materials. So now you look at the various structure. Maybe some cases we have to understand the structure of the material, how the lamellar or how the carbons are present. Okay. So in most of the cases you can see the grains having same uniformity. Once if you have some white appearances with the correct grains, uniform grain it is open mean it is come under ferrite material because it's a carbon. And some cases we can see the structure having different grains. You can see the changes. Some lamellars are separated. Can I give the point? So the white appearance is called ferrite and the formation it is come under pearlite. So in austenite you can see some of the needle-like appearances. Can you see the thing? So this is come under austenite material, and this is the martensite structure. It is having some again a needle-like lamellar structure will be produced. So once if you observe this kind of microstructure, we can point out it is a martensite material because martensites are produced when austenites are slowly cooled. Okay, so this is a structure. And ledubrate, it is a form of a group of pearlite and carbon. So this is a structure for ledubrate material. And last one will be Swarbite. So you can look at the formation of cementite and ferrite. So the white appearances are ferrite and a group of structures. Can you see the thing? So this is come under Fe3 in the form of cementite. So once if you find this lamellar appearance, you can confirm the metal is Swarbite. Okay, and last one is you have see the carbons in the form of ferrite. Okay, so it's a very rich carbon. So it is come under a formation of cementite is a carbon and white appearances are come under ferrite. So Trosite is another form of material. So it is like a uniform distributions of the carbon. Okay, spherical shape. So it is a similar fashion, only thing how the structures are modified. Okay, so most of the cases we have transformation is happened only the cooling stages only. Okay, so all the cases austenite materials are rapidly cooled or slowly cooled, it will produce ferrite and pearlite. Pearlite is nothing but it is a combination of ferrite and cementite. So once if you understand this terminology, we can able to answer all the things. Okay, so these are the various microstructure. Now I will show on a good example. A single picture you can get all the transformation: austenite, pearlite, sorbitic, nodular, martensite and sorbite. So in all the cases you can look at the hardness. So the BH is nothing but Brinell hardness number for austenite phase is 200. So austenite I already show it is like needle form structure. Okay, can you find the needle? So it look, once if you find this kind of structure we can confirm it is a austenite material. The hardness will be 200, and pearlite is nothing but combination of ferrite and cement. The hardness will be 180. So this is appearance. And the sorbitic pearlite is the formation of ferrite and cement. It is a group of materials are gathered. Can you see the thing? And this is a spherical shape. Once if you confirm the spherical shape appearance, you can say it is a Trosite form. The hardness is around 450. Okay, so it is very high hardness. Last one, the 700 Brinell hardness number is attained for Martensite structure. Martensite means austenite is suddenly cooled. So this is appearance. You can see the lamellar forms of appearances. The hardness is very high for martensite state. Okay, and last one is sorbite. Sorbite is once again a combination of alpha and cementite. The cementite is nothing but carbon. So more carbons are involved, but it is a uniformly spreaded. Okay, so once if you find this kind of structure, we can confirm it is a sorbite structure. It having a range of 400 to 250 is the Brinell hardness number. So in all the cases, Martensite attained only the maximum hardness number. It is very, very important microstructure. It may have some questions regarding the micro consist of iron carbon alloys. Okay, so my suggestion, please understand the different microstructure. So 700 is the maximum Brinell hardness number for the Martensite material. Maybe they'll ask one questions regarding this particular area. Okay. Next, we move to iron carbon diagram. It is very, very essential. You can get lot of questions from this particular area. So we are already studied the iron carbon diagram in your second year or maybe in the first year. So now once again we have to revise or just recollect the informations what we have studied. Okay. So first of all, it is come under a phase diagram only because it having some different phases are formed. Okay. So it is a graphical representation of carbon in x-axis and variable of temperature in y-axis. And you got the point? So it is a graphical representation. In x-axis, we have to keep weight percentages of carbon. In y-axis, temperature. So I can maintain the temperature in the form of degree centigrade. Okay. So first, the information we have collected is 0.008 percentage is the iron, pure form of iron. Okay, from 0.08 to 2 percentage of carbon, we can call it as steel material. This is the first classification made based upon the weight percentage of carbon. And I got the point. So iron, very limitation of 0.08 percentage of carbon only. Okay, whereas in case of steel, the material should be range from 0 to 2 percentage. It is come under steel category. Then 2 to 4.7 to 4.7 is the maximum weight percentage of carbon involved. So it is come under cast iron. So cast iron having more weight percentage of carbon, but the property will be changed from ductile to brittle. Please keep in mind. Steel, you can give many examples. Steel rods, construction material, shaft, it's all come under steel. Again, the steels are made into three type: low, medium, high carbon. In low carbon steel, the component of composition of carbon is 0 to 0.25 percentage. From 0.25 to 0.5%, it's come under medium carbon. Okay, so low carbon steels, what is the unique properties? Ductility and good weldability. So that's why most of the construction materials are used low carbon steel, because it having good ductile and weldability. Medium carbon steel is 0 to 0.5%. We have increased some amount of carbon. As a result, strength and toughness will be very high. That's why most of the railway wheels, railway tracks are made into low carbon steel. Then last category is high carbon steel. High carbon means 0 to 2%. Maximum percentage of carbon is 2. These materials are helped to get stainless. So more percentage of carbon, hardness and corrosion resistance will be increased. Most of the stainless steels, cutting tools are all come under this category, stainless. Okay, knife. So you can give many good example, but these content are come under weight percentage of carbon only. But in case of cast iron, we have range of carbon from 2 to, you can look at the bottom, the range of carbon from 2 to 4.7 is the maximum. Some cases 2 to 6.67, but this is a maximum limit, but practically they are not beyond 4.7. Okay, so 2 to 4.7 is the maximum weight percentage of carbon is come under cast iron. So cast iron, you can give many example. Motor casing is a good example for cast iron material. Couplings, flange couplings. Okay, ஹவுஸ் ஹோல்டு யூஸ் பண்ணுற பேன் சொல்லுவீங்களே, இது எல்லாமே வந்து கேஸ்ட் ஐரன்லாம் வருது. ஓகே, ஸோ சிலிண்டர்ஸ், ஐசி இன்ஜினில் யூஸ் பண்ணுற சிலிண்டர்ஸ் இஸ் a good example for cast iron. So lot of application. When we speak, when you hear about the term cast iron, more hardness, that is very, very, very important. Cast iron is a hardness and brittle material. Okay, so these are the particular information from the weight percentage. And one more thing is, we have 3 important terminology should be used: Eutectoid steel, hypo-Eutectoid steel, and hyper-Eutectoid steel. So can you see the bottom? Eutectoid steel means 0.7% of carbon. Once if it has 0.7% of carbon, you can call it as Eutectoid steel. If having less than 0.7% of carbon, it is called hypo-Eutectoid steel. You can look at the bottom, hypo-Eutectoid steel. It having percentage of carbon is 0.7, less than 0.7. Once it having above 0.7% to 2%, it's come under hyper-Eutectoid steel. Because in this particular session, I'm going to discuss about the transformation of Eutectoid steel. So that's why I suggest you to understand the bottom. Iron 0.08% of carbon, steel 0 to 2% of carbon, cast iron 2 to 4.7% of carbon. Can you got the point? This is very essential. Again, we have made a classification of 3 important terms. Eutectoid steel having 0.7% of carbon, hypo-Eutectoid means less than 0.7% of carbon, hyper-Eutectoid means 0.7 to 2% of carbon. So this is particular information is very essential for the phase diagram. So we have identified the different material based upon the percentage of carbon. Okay, fine. Now you can look at the y-axis is temperature. Now we are going to move for the different phases. Can you see the symbol alpha? It is ferrite. Okay, so already I just suggested ferrite is the interstitial solution of carbon in iron. So what is the percentage of carbon is 0.025% of carbon is involved. The maximum stable temperature for ferrite is 910 degrees centigrade. So can you see the end? So from 0 to 910 degrees is the stable temperature for ferrite material. The ferrite symbol will be alpha. The percentage of carbon is 0.025%. It's nothing but the carbon is added in the iron. It is called interstitial solid solution, and the stable temperature is 910 degrees centigrade. So this is the first phase we have identified from the phase diagram. Second, from 910 to 1400 degree. Can you see the point? So this is the particular area where austenite is transformed. From ferrite to austenite, enga kadachirukku pathinga appadina, starting point from 910 degree to 1400. So we have obtained the austenite structure or austenite phase. Eppadi neenga sollalam. So austenite ku maximum percentage of carbon is 2. Can you got the point? Ferrite we have only 0.025% of carbon, whereas in case of austenite the maximum weight percentage of carbon is 2 and stable temperature is 1400. So we can use the symbol gamma for the austenite phase. Okay, and from 1400 to 1538 in this region, again austenite is changed to delta n. Can you see the symbol? Delta n is a 1 second delta Ferrite because phase center cubic structure is changed to body center cubic structure. That's why we have to say delta n is also come under Ferrite structure. So the stable temperature pathing abdina 1538. So this particular region we can call it as delta n, but we have limited the percentage of carbon only 0.08. Okay, so these are the three important phases as produced while changing the temperature, while changing or composition changed. So different composition, different temperature, the different phases are transformed or changed. Okay, so this is the particular informations we have collected from the iron carbon diagram. So next, I just want to share some of the important reaction. Already we have studied about the reaction. One will be eutectic reaction, eutectoid, peritectic. So these are the three important reaction. So you can see the particular composition, particular temperature. So this is eutectoid, where one solid produce two solid at a temperature of 727 degree centigrade. ஒரு சாலிடு ரெண்டு சாலிடாக ப்ரொடியூஸ் பண்ணும். இந்த பர்டிகுலர் டெம்பரேச்சர் பார்த்தீங்கன்னா 727 degree. The percentage of carbon is involved is 0.8%. Okay, so I will show the structure, you can able to understand. So in eutectoid, what is the symbol in this area? Austenite. So gamma temperature 727 degrees temperature, percentage of carbon is 0.8%. Okay, so eutectoid means ஒரு சாலிட் ரெண்டு சாலிடா ப்ரொடியூஸ் ஆகும். ஒரு சாலிட் என்னது? S1 the sense gamma, S2 alpha, S3 cementite. So this is called eutectoid reaction. Okay, anyway we'll explain the next slide. So before that we have to understand the single phase diagram with lot of information. Okay, so this is called eutectoid reaction. Now can you see the point where this is called eutectic? Eutectic means one liquid is going to produce two solid, S1, S2. So this is the point where eutectic reactions are started. So what is the temperature? 1148 degree is the temperature, and the percentage of carbon involved is 4.3%. So one liquid is going to convert it into gamma, the solid one, and cementite is the solid two, that is called carbide. So this is the eutectic reaction, and you can find the third reaction is peritectic reaction. So this is area where we can see one liquid plus solid is going to produce second solid. So L plus delta, can you see the symbol? L plus delta is going to produce gamma, austenite material. So this is the region where peritectic reaction is going to observe in the particular area. So we have get lot of information from the single diagram. So some cases we have to parallelly construct the microstructure also. Some cases means some slide or some notes or some data, they will parallelly construct the microstructure. Ferrite எப்படி இருக்கும், austenite எப்படி இருக்கும், டெல்டா எப்படி இருக்குன்னு சொல்லிட்டு மைக்ரோஸ்ட்ரக்சர் பேரலாக வரைஞ்சிருப்பாங்க. நீங்கள் அப்படி தான் பண்ணணும் நெசசிட்டி கிடையாது. ஒன்ஸ் இஃப் யூ அண்டர்ஸ்டாண்ட் த வேரியஸ் phases, particular temperature, composition in the sense weight percentage of carbon, and what are the reaction. So once if you clear this content, you can able to understand the informations. Okay, so these are the particular informations we have collected from the phase diagram. So ஒரே ஒரு ஸ்லைடை வச்சு நம்ம நிறைய இன்ஃபர்மேஷன்ஸ் வந்து லேர்ன் பண்ண முடியும். So it's like a kind of revision only. So I just done something. So once again I will share the important thing. You can able to identify or differentiate the different material, steel and cast iron, based upon the weight percentage of carbon. So steel now 0 to 2% in the steel, 2 to 4.7% of carbon we can call it as cast iron. Again, we have three mode of steel material: eutectoid steel, hypo-eutectoid steel, hyper-eutectoid steel. Hypo means less than 0.7 percentage, hyper means 0.7 to 2 percentage. Okay, so these are the particular content which we have obtained with the help of iron carbon diagram, or sometimes we can say it is a phase diagram. Okay, so I will move to the next one. I hope you can understand the thing. So this is the thing where we have obtained it with the help of iron carbon diagram. So iron is having less than 0.08 percentage of carbon, and steel it is come under 0 to 2.14 percentage. So usually they won't make more than 1 weight percentage of carbon. Some cases, but cast iron is differentiated from the steel because more percentage of carbon is involved. So 2.14 to 67.7, but practically they won't beyond 4.7 weight percentage of carbon. So this is one of the particular information. So you please understand the range of carbon for different materials. Sometimes they make a question, they frame the question based upon the weight percentage of carbon. Is it clear? So it is all come under ferrous base because iron. So it is, we can call it is ferrous material. Non-ferrous means absence of iron, like polymers, ceramic. It is all come under non-ferrous material. So it is a different sector. So we don't touch upon the non-ferrous material and all. Okay, so we have to quite interest with this percentage of carbon for different material. Okay, so once again, please revise or understand the percentage of carbon for different material: iron, steel, and cast iron. Okay, I hope you can clear this slide. I just move for the next one. So these are the particular information we already studied or already discussed in the iron carbon diagram itself. So ferrite is a symbol of alpha. It is the interstitial solid solution of carbon. In iron, it having BC structure. So delta is once again the interstitial solid solution of carbon in iron. It having phase centered cubic structure. The stable temperature is 1395 degree. Okay. So delta ferrite is another solid solution of carbon. Its structure is changed from FCC to BCC. The maximum stable temperature is 1538. And another important information is Fe3 is a iron carbide. Sometimes we can say it is a cementite material. It having 4.7% to 6.67% of carbon. Okay. So what are the particular properties for a cementite? Is very hard, brittle, strength. Okay. So the properties are purely depend upon the microstructure, how the ferrite and cementite are mixed. So this is very, very essential thing. So the properties is purely depend upon the weight percentage of carbon, modification of the microstructure, and the end results. So these are the properties depend upon the variables only. Okay, variable in the sense temperature and composition of the component. So comments on the FFE system. This is particular information we have studied. This is look at the very good informations from the iron carbon diagram is reaction. Already I suggested you three important reaction in the phase diagram. One, peritectic, it's a high temperature. Eutectic, 1147 degrees centigrade. Eutectoid, 727 degrees centigrade. So this is easy to understand. You can say peritectic means L plus S1 equal to S2. Okay. For your understanding purpose, we have to make a symbol of L plus S1 equal to S2. So you never forget this phases. Okay, so easily understand பண்ணோம் அப்படின்னா நீங்களே என்ன பண்ணலாம், ஒரு பென்சிலோ ஒரு பேனலோ நீங்க நோட் பண்ணிக்கலாம். என்னது L plus S1 equal to S2 அப்படி நாம வச்சுக்கீங்க. Okay, so L in the stands for liquid. It is a one solid in the form of delta ferrite. So L plus S1 equal to S2. S2 produce அந்த பார்த்தீங்கன்னா austenite. இது எப்போ சார் ஃபார்ம் ஆகும் அப்படின்னு பார்த்தீங்கன்னா under cooling process. Okay, so once you start to cool the material, you have to produce the second solid of austenite. So what is the temperature is 1493 and percentage of carbon involved is 0.18%. Sometimes they will ask the question, what is the range of, what is the particular temperature for peritectic reaction? Okay, Then eutectic is another important reaction, because this term you are familiarly used to for the cooling curves. So you can expect some question in the cooling curve also. So some if you have any time, you have to discuss the cooling curves. Okay. So eutectic means L equal to S1 plus S2. ஒரு liquid ரெண்டு சாலிடா ப்ரொடியூஸ் ஆச்சுன்னா அதுக்கு பேர் eutectic நம்ம சொல்லலாம். Okay. So you can easily understand L equal to S1 plus S2. So liquid, I can make it a symbol L. One solid in the form of gamma, it is called austenite and cementite, Fe3. So what is the temperature involved for the eutectic reaction is 1147 degrees centigrade, and the weight percentage of carbon is 4.3. Okay. So this is the reaction happened in the particular area or particular location. It is available in the iron carbon diagram. You can find the correct area. Okay. So now you quickly move to the last section is eutectoid. So eutectoid is nothing but one solid S1 is going to convert or transform to produce two solid S2 plus S3. So gamma is going to change or transform to produce alpha and cementite. So this reaction is happened at a low temperature of 727 degree, and the weight percentage of carbon involved is 0.77. So this is the particular information we have collected. So parallelly you have to check the structure. So delta Ferrite is a BCC paramagnetic. Sometimes they can ask the particular property for the structure. Okay. So austenite, we have to understand the FCC structure is a non-magnetic and ductile. Delta BC structure, fairly ductile. Cementite, orthorhombic structure, hard and brittle. Some case they particularly identify the structure and property. Okay. So the maximum percentage of carbon involved is ferrite is very, very less. Already I point out 0.025 percentage. Austenite only 2.11. So you have to identify the reactions happen in the iron carbon diagram. Is it clear? I hope you can understand the reactions for different material. So once again, L plus S1 equal to S2 for peritectic. In eutectic, L equal to S1 plus S2, and third eutectoid, S1 equal to S2 plus S3. So in eutectoid, there is no involvement of liquid phases. So that's why we simple remembrance you have to keep in mind. So no liquid will be involved in the eutectoid. So eutectoid means low temperature. Okay. So it's like a hint you can for your understanding purpose. நீங்க ஈஸியா ஞாபகம் வச்சுக்கணும்னா இந்த மாதிரி நீங்க படிக்க ஆரம்பிச்சிடலாம். ஓகே. ஸோ கண்டிப்பா ரியாக்ஷனை பேஸ் பண்ணி ஒரு கொஷின் கம்பல்சரியா இருக்க பாசிபிலிட்டிஸ் இருக்கு. ஸோ அதனால நீங்க இந்த ரியாக்ஷன்ஸை கொஞ்சம் அண்டர்ஸ்டாண்ட் பண்ணீங்க. சரியா? Okay, fine. I can move for the next one. So these are the various reactions happened in the iron carbon diagram. We already discussed, so I'm not going to make much important. I can share the thing. Okay, so this is the particular location where we have to find the conversion or transformation from liquid to produce two solid. So what I suggest, so this is the area where we have to find the eutectic reaction at around 147 degrees centigrade. So liquid is going to produce two solid in the form of alpha plus. Okay, so you can look at the reaction for liquid, and the slow cooling process is going to convert solid 1 and solid 2. Okay, so the same solid heat panina now it will be transformed to liquid. So it's a reversible process. Okay, so you can see L equal to S1 plus S2. So for your understanding purpose, liquid is going to produce two solid, one in the form of austenite, another the solid of cementite. Is it clear? So this is a peritectic reaction, is occurs at the maximum temperature. So ஒரு liquid ஒரு solid சேர்ந்து second solid produce ஆச்சுன்னா அதுக்கு பேரு peritectic reaction. So it is a high most temperature. So you can see some example of can you see the point where this is the correct location? L plus S1 equal to S2. So you can take many example of like bismuth, tin, lead, okay, antimony. So these are the good examples, silvers. So there is many reactions happen for the particular formation of system, okay. So tin based alloy, okay, copper based, antimony, bismuth, tungsten. So we can many alloys are produced based upon the peritectic reaction, okay. So different composition are obtained in this peritectic form of reaction only. So you can, many examples are there. So SB, SN. SN stands for tin material, okay. So this is the particular where I just suggested Eutectoid is occurred at low temperature only. So how one solid is going to produce two solid, S2 plus S3. One solid in the sense gamma. So gamma is going to produce alpha and cementite. So this is the one good example for eutectic reaction is copper, aluminum, copper, zinc, tin, aluminum, manganese, beryllium. So we can give many application or good examples for the eutectoid reaction. So this reaction you can find in the iron carbon diagram itself at the low temperature of 727 degree centigrade. So at this particular temperature, the transformation is happened from S1 equal to S2 plus S3. So you can keep remember this reaction. If possible, you can have some good example like copper aluminum, copper zinc. So most of the reactions are involved in the application of steels. Variety of steel we have framed. Some alloy-based steels are also produced through this reaction only. Okay. So alloy-based steels are morely preferred for corrosion, high resistant of temperature, wear resistant. So for this particular application, we have to have some alloy element. Okay, so particular alloy should be added. So aluminum based or maybe zinc based or tin based. So any alloy materials are helps to find out the or improvement of the mechanical property. Okay, so please remember the reaction. So this is the where we have find out the low temperature. I already said 723 degree centigrade. Gamma is going to produce alpha and cementite. Okay, so S equal to S1 plus S2. So this is the reaction. So I hope you already familiar with this term, reaction, temperature, and phases. Okay, so you are familiar with phase means ferrite, austenite, cementite, pearlite. இதெல்லாம் உங்களுக்கு கரெக்டாக தெரிஞ்சிச்சுன்னா நீங்கள் ஈஸியாக ரியாக்ஷனை எழுதிடலாம் சரியா. Okay, I hope you can understand the different reactions. So this is the last one, peritectoid also there is no involvement of liquid. So solid 1, solid 2 produce solid 3. So for particular application like nickel, zinc, iron, uranium, copper, tin, molybdenum, so these are the good example for formations for the peritectoid system. So most of the alloy based application we have to go for some solid reactions only. So peritectoid and eutectoid morely involved for the alloy based applications. Okay, so many steel based applications you can remember the materials for particular area. So this is the thing which I want to share you, because this content are very important aspect for the CATE preparation, because some questions are framed regarding this content. If you are possible, you can check the previous question paper, you will get some questions. Okay, so before going to that, I will touch some of the classification of eutectoid steel, hypo-eutectoid and hyper-eutectoid. So in steel we have the percentage of carbon from 0.008% to 28% of carbon. Is it right? Okay, so from if a steel contain only 0.8% of carbon, we can call it as eutectoid steel. Is it right? But maximum 0.7% only is limited. Okay, some cases they have to prefer 0.8%. So you can keep 0.7. So if you're having more than 0.8% of carbon, okay, if you're having more than 8% of carbon, we can call it as hyper-eutectoid. If it is less than 0.8% of carbon, we can call it as hypo-eutectoid steel. I already point out in the iron carbon diagram at the bottom itself. Okay, So once again, if possible, you can note down this percentage of carbon involved for the steels category: eutectoid, hypo, and hyper. Okay. So next, I want to share some of the informations regarding the transformation of the eutectoid steel, because transformation means the third phases of the materials are produced, changed by cooling the material. Okay. So once if you particular temperature we have to allow to heat. After heating process, the sample should be allowed to cool to get the different microstructure in order to improve the mechanical property. So that's why we have to speak about the many transformation, that is called transformation of the eutectoid steel. So what I'm going to do is, so this is the first case I'm going to consider for the transformation of eutectoid steel. So we are aware that eutectoid steels having the percentage of carbon is 0.8 percentage. So the steel should be heated about 750 degree and holding for a sufficient time. I can take 3 hours. I'm going to hold the specimen for 750 degree. Then this entire structure of the metal is homogeneous austenite. You look at the change. At 750 degree, I just heated the sample for 3 hours. The structure of the metal is a complete homogeneous austenite. The symbol will be gamma. Okay. So the process is called austenitizing. Then the samples are allowed to cool. Sample are allowed to cool. What will happen? The austenite is gradually changed to ferrite. Then the ferrite will be changed to perlite. So this is the modification or transformation happen for the particular eutectoid steel. What is the purpose or what is the application? Once if you modify the microstructure, ultimately we can improve the mechanical property, especially hardness will be increased. So that is a major improvement. Okay. So I will show the example. So before that, you have to understand about the term perlite. It is a mixture of ferrite and cementite. Once again, remember the term already we have discussed. So you just remind the term. Perlite is nothing but it's a eutectoid mixture of ferrite and cementite. So maximum weight percentage will be 87 and 12.5 percentage of carbon. That is called cementite, more carbide. Okay. So this is a particular slide which I want to show to you. So you have to heat the specimen for 750 degree for 3 hours. The entire structure will be austenite. Is it right? So alpha will be produced. Then the alpha is going to convert into perlite. Perlite is nothing but formation of ferrite and cementite. So what is the property we have improved? Now look at the thing. The perlite has a properties of intermediate soft, ferrite and hard. So this is very, very essential. The hardness will be improved by the transformation of the material. So now you look at the thing. This is the point A and B. So I am taking the sample of 0.8 percentage of carbon. The sample should be allowed to heat at 750 degree for 3 hours. Okay. Now at the point you can look at the entire microstructure. The entire microstructure should be in the form of austenite. Okay. So now you can look at the face. It is entirely austenite material. Okay. After that, the sample should be allowed to cool. Allowed to cool means at a particular point B, you can see the temperature around 710. Okay. What is that structure? The small nucleation of alpha will be formed. Can you see the area? So 50% of ferrite, almost 50% of ferrite will be formed, and remaining 50% are made from cementite. Once the cementite and ferrite is formed, we can call it as perlite material. Very simple. ஒரு eutectoid steel set ஹீட் பண்ண 750 டிகிரில ஹீட் பண்றப்ப எனக்கு பாத்தீங்க அப்படின்னா என்டையர் அஸ்டனைட் ஸ்ட்ரக்சர் தான் இருந்துச்சு. செகண்ட் அந்த சாம்பிள்ஸ் நான் கூல் பண்றப்ப என்ன ஆகும் அப்படின்னா அஸ்டனைட் வந்து கிராஜுவலா ஃபெரைட்டா மாறும் 50%. அந்த ரிமைனிங் 50%ல இருந்து 12% செமெண்டைட்டா மாறிடும். அப்ப ஃபெரைட் அண்ட் செமெண்டைட் சேர்ந்ததான் நம்ம என்ன சொல்லியிருக்கோம், பியர்லைட் அப்படின்னு சொல்லியிருக்கோம். அப்ப இந்த ஃபார்மேஷன் பியர்லைட் இருந்துச்சுன்னா என்ன ப்ராப்பர்ட்டி இன்க்ரீஸ் ஆகும் பார்த்தீங்கன்னா மெட்டீரியல் வந்து கொஞ்சம் டக்டைல் and hardness improve ஆகும். Can you got the point? So once again I repeat the expression. So this is a particular point where the samples are allowed to heat at 750 degree. At the particular temperature, the entire microstructure in the form of austenite, the symbol will be gamma. Then the samples are allowed to cool for below 700 degree. What will happen? the entire austenite is going to converted or transformed to alpha and cementite. So once the mixture of alpha and cementite is called pearlite. So this is the appearance for the eutectoid steels. You have to get some question based upon the transformation of the steel. What is the combination of pearlite? What is the combination of austenite? So some case we have to understand about the various phases. Is it clear? So eutectoid steel is the temperature is 750 degree. So next I'm going to take the hypo. Hypo means less than 0.8% of carbon. So what I'm going to do is I can take the material of 0.3% of carbon is heated at 875 degrees centigrade. You can take the point A, 875 degree is the sample I heated. So what will happen? The entire structure in the form of austenite. Then the samples is slowly cooled at a point, the temperature around 750 degree. 50% of austenite is changed to alpha. You can see the small nucleation development of ferrite. Can you see this thing? So small ferrite has developed and remaining 50% are austenite. So 50% conversion is happened at particular temperature. Second, again the samples are allowed to cool. So 730. 80% of austenite is converted into ferrite. The small development of the nucleation is as make to grains. It's a long chain of grains are produced here. And at this particular temperature of 700 degree, almost all the austenite are converted to form of pearlite. So pearlite means mixture of ferrite and cementite. But here we have to see some protectoid alpha and eutectoid alpha. Can you see the thing? So some formation of eutectoid steels are developed along with the pearlite. So protectoid and eutectoid formation is developed. So where in case of hypo-eutectoid steel, but in previous case we could not find this transformation. Can you got the point? So below 0.3%, below 0.8% of carbon, we have to get different microstructure. So this is the essential thing. We have find out the less carbon, 50% conversion, and 80% later all the austenite is changed to pearlite. So pro-eutectoid and complete eutectoid. So alpha. So this is a good example for hypo-eutectoid steel. You can find the pro-eutectoid is the appearance of white color. Okay. So once if you observe in the microscope, you can find this structure only. So the green colors are highlighted as a pro-eutectoid and remaining red color are formed in the carbon in the form of Fe3, cementite or carbon. So alpha and ferrite, so alpha and cementite is called pearlite. So we can say it is a pearlite structure. So it is one of the transformation. You have to get question based upon the changes. Is it right? So the last one is transformation of hyper-eutectoid steel. So what I'm going to do is I'm taking the sample of 0.8% to 1.1% of carbon. So more 8% of carbon I'm going to take. So what I'm going to do is I'm selecting the sample of 1.2% of steel. The sample should be heated at 925 degrees centigrade and holding for sufficient time. Means 3 hours I'm going to hold at 925 degree centigrade. What the thing will be happened is the entire austenite is going to change into pearlite. I will show the picture. So this is the informations we are going to find the hyper-eutectoid steel. Hyper means more than 0.8. So what percentage of carbon I am taking is 1.2% of carbon I am going to consider, and the sample is allowed to heat at 925 degrees centigrade. What will happen? At 925 degrees centigrade, the microstructure are appeared as the entire austenite. Look at the thing, gamma. Next, the sample is allowed to cool for 850 degree. 50% of austenite is changed into cementite. Can you see the small nucleation development? So this is a formation of cementite is developed. Next, below 727 degrees centigrade, all the austenite is changed into pearlite. Pearlite in the sense eutectoid formation and pro-eutectoid formation. So this is the generation of the pearlite structure. So what happened here? Cementite is developed under 850 degrees centigrade. So this is the particular information we have collected based upon the change in temperature. So once if you sample allowed to cool, the microstructure modification will be happen. So that is a particularly or experimentally we have to investigate at the microstructure what transformation is produced under slow cooling process. So this particular information helps to find the better mechanical properties. So this is the microstructure we have obtained. So in all the cases we have to say the form of pearlite only. Okay, so this is the particular sample where we have to see some of the river-like appearance. Can you find the some white river-like appearance? It is called Eutectoid. So this is area where we have to say it is a Eutectoid. Can you see the thing? And remainings are form of pearlite only. It's a alpha. Okay. So this is the particular transformation happened in the hyper Eutectoid steels. Okay. So you can look at the thing. So this is the formation I already suggested you. So where we have find some river-like appearance is all come under Eutectoid. So this is nothing but area, and remainings are all come under alpha. The blue color will be represented. So alpha and cementite is called pearlite. So once if you observe this kind of image, we can confirm it is a pearlite structure. Okay. So this is the practically observed for the variation of temperature, variation of composition of the carbon content. So this is the particular informations we have collected from the different material. For your understanding purpose, we have to remind the term pearlite, eutectoid, pro-eutectoid. Is it clear? So I don't want to take much time. I just move to classification of cast iron. So we people are much aware that cast iron is a more percentage of carbon. So once if you hear the term cast iron means more hardness material and brittle material. Okay, so you can give many example. The pump casings are made from cast iron, couplings, okay, engine cylinders. These are the good example of cast iron material. More hardness, high temperature resistant, but the drawback is brittle nature. Okay, so what is the limitation of carbon is 0 from 2 to 4.48% of carbon is involved. Okay, some case other alloy elements also increased for the better mechanical property. So these are the 4 important types of cast iron. We have to come into the picture: gray, white, nodular, malleable. Okay, so these are the 4 variation of cast iron: gray, white, nodular. So based upon the fracture appearances, we have to decide the type of cast iron. So once if it is a gray color, we can confirm it is a gray cast iron. If it is white, we can confirm. So based upon the structure of the carbon, we can say it is a nodular and property. Okay, so these are the 4 important classification of the cast iron. 1 second, I tell you the percentage of carbon for cast iron is 2 to 4.7 percentage. Okay, 2 to 4.7 percentage. The unique properties of cast iron is hardness is very high, more hardness, high temperature. The drawback is brittle nature. Brittle na abdina metal deformation illama sudden failure aidum. That is called brittle nature. Okay, so cast irons are come under brittle category. So now you look at the first category of gray cast iron, because you can see the appearance are in gray color. Okay, so this like a flakes of carbon. See, we can say it is a graphite. Graphite is nothing but a carbon. Okay, so flakes of many carbons are represented in the microstructure analysis. Okay, so gray has a name because the fracture surface appeared in a gray color, so we can call it as a gray cast iron. So it having many flakes of carbon which consist of ferrite, pearlite or mixture of the two. So most of the cases, the appearance of alpha and pearlite only. So what is the advantage of gray cast iron is, so it's a very high damping capacity, in the sense vibration will be resistant material. So more vibration resistant material and good dry bearing qualities due to presence of graphite material. So you can keep one important advantage of gray, it is a high vibration or damping capability. So anyway, in the next slide I will show the example and you can easily catch up. So white color, you can see the appearance of the structure in the form of white. So it is come under white gray cast iron. So it is having a unique properties. So hardness and very good abrasion resistant, but very brittle nature. So this is a quite drawback of the white cast iron material. And this is a combined of many carbons or carbide are present. You can see the black color, it is more carbides are involved. Please go through the first one, because 2001 one gate questions are framed from the white cast iron. White cast iron is a unique in that the only member of the cast iron family in which carbon is present in the form of carbide. Okay, so the combined of carbon or carbide is called white cast iron. That is a uniqueness. Then due to absence of graphite, so in previous case we have see some flags, is it right, like needle like appearance, okay, but here we don't have any needle like appearance, okay. So absence of graphite is a light appearance, it's a white color, you can see the thing center, this is white appearance. And the unique properties of white cast iron is extremely hard abrasion, but the drawback is very brittle nature, okay. So the third category is ductile cast iron, because you can see sometimes they can call it as nodular because the carbon in the form of nodal-like structure. Can you see the thing? Remaining are matrix. Remaining matrix in the sense alpha. So what is the uniqueness? Okay. So the structure is developed from the melt. Melt means while heating all the most of the cast irons are produced by cupola furnace only. Is it right? So in the case, all the metal should be heated to melt. So different charges are being used for cupola furnace. Okay, so charging material, some flask, so different things we have to maintain cupola furnace. So charging area, okay, so charging temperature, melting, so different things we have to understand. But I don't want to touch much the thing. Once if you find the nodular like appearance in the is unique of ductile property, and the maximum strength is 380 to 450 megapascal. When compared to other thing, this material is having high tensile strength. So some good application for the ductile based materials are including pumps, motor casing, valves, crankshaft, gears, and other automotive components. So majorly the machine components are made from cast iron. Even you can take some lathe machines are all come under ductile cast iron only. So it is a quite application. So my suggestion, you have to understand the microstructure of the nodular cast iron. Once if you find the spherical shape of carbon like appearance, you can confirm it is a nodular or ductile, because the ductile is appeared due to presence of magnesium, sodium. And last one is malleable cast iron. So if a cast iron is rapidly cooled, the graphites rapidly cooled. From the gray cast iron, it is converted into malleable. So this is the particular microstructure for the material. So the carbon should be in the form of sorry. So this is the particular applications of different materials. So please go through the slide. Okay, so it's a so this slide have a plenty of data. So in the previous we have discussed about the many cast iron. So we have to find the particular application of the material. So I can say the grade of Society of Automotive Engineers SAEG 1800. Look at the percentage of composition. So 3.4 to 3.7% of carbon is involved. 2.5% of silicon, remaining are manganese, and the structure is ferrite and pearlite. The strength will be 124. And the application wise, some casting engine, liners, cylinders, pistons, piston blocks, clutch plates, all composed of gray cast iron only. Okay. The ductile category, the percentage of carbon is 3.5 to 3.8, 2 to 2.5% of silicon, some content of 0.5% of manganese, and the structure is pearlite and ferrite. So it's a quite application of some bodies like casings, material, walls, gear, and machine components. Okay. So last one, malleable. It having a good tensile strength and more ductile also. Okay. So this is the information. So almost all the cases, some presence of silica, manganese plays a vital role for modifying the or changing the properties of the material. Is it right? So in this first module, I just completed some of the content related to phase diagram, transformation of steels, various reaction, cast iron. So these are the some reference book you can refer. You will get lot of informations. Okay, so now you have some discussion about the module 1. Okay, so phase diagram la ஒரு question யார் ஆன்சர் பண்றான்னு பார்க்கலாம். So I can find the question from 2021, the set 2, question number 4. The cast iron which possesses all the carbon in the combined form as a cementite is known as gray, spherical, malleable or white. இதுக்கு என்ன ஆன்சரா இருக்கும் ஸ்டூடெண்ட்? From student side, this is a gate question from 2021. The cast iron which possesses all the carbon in the combined form as a cementite. Cementite means carbide. என்னவா இருக்கும்? Which material having more carbide? Any quick answer from student side? Sir, please. Your answer. What's your suggestion or idea? Which one is the correct answer? A, B, C, or D? Any response from student side? Which one is correct? A, B, C, or D? Any response from student side? Ravidharan, Abhinash, Narkesh, Raj. But 30 students இருக்கீங்க ஒருத்தர் ரெஸ்பாண்ட் பண்ண மாட்டீங்க. Someone has mentioned any answer from student side? C is not correct. Any answer? Any answer from student side? The cast iron which possesses all the carbon in the combined form of cementite is 2021 gate question. இப்போ நம்ம நடத்தின கண்டென்ட்லேயே அதுக்கு ஆன்சர் இருக்கு. Anyone find to judge the correct answer? Which one is correct? Out of 39, only one responded. Okay. Any try or any guess? The possible answers. யாருமே ட்ரை பண்ண மாட்டீங்க. Harish. Any answers from student side? No. So nobody interested to answer. Is it right? Okay, fine, no issue. I will tell the thing. So D is the correct answer. White cast iron has a more combined form of cementite. Okay. So second question. So can you find the question? Gate 2020. It is a framed question on the phase diagram. Which one of the following? Anyway, I'll make it a full screen. Which one of the following statement is about a phase diagram is incorrect? Anyone? Any guess or any try regarding this phase diagram? Which one of the following statement a phase diagram is incorrect? In the beginning of the slide itself, I just suggested the information of the phase diagram. 4 points I presented. Okay, so what is the correct or incorrect? They asked to find out the incorrect answer from A, B, C, D. Any guess from student side? Quick answers. Any guess from student side? Student A. It indicates the temperature different phase start to melt. No. இன்கரெக்ட் கேக்குறாங்க, கரெக்ட் கேட்கல அவங்க. they has to find out the incorrect. இந்த பாயிண்ட் நம்ம ஆல்ரெடி இண்டிகேட் பண்ணியாச்சு. at which different phase start to melt ன்றது இருக்கு. it indicate the temperature. It indicate the temperature at which different phase start to melt இருக்கா? அப்ப இது வந்து கரெக்ட்டா இன்கரெக்ட்டா?
ஆப்ஷன் சி சார்.
ட்ரை பண்ணுங்க, தப்பே கிடையாது. அட்லீஸ்ட் என்ன லேர்ன் பண்ணீங்கன்னு பார்க்கலாம்ல. Any good answer from student side? So A is not correct pa. Okay. அதான் சொல்லிட்டேன், இன்ட்ராக்ட் பண்ணுங்க. தப்பா இருந்தா பரவாயில்ல, அட்லீஸ்ட் என்ன நாலேஜ் நம்ம கெயின் பண்ணணும்ன்றத பார்க்கலாம். ஓகே, ட்ரை பண்ணுங்க. அட்லீஸ்ட் இன்ஃபர்மேஷன் ஃப்ரம் ஃபேஸ் டயக்ராம் நம்ம ஃபர்ஸ்ட் ஸ்லைடே பார்த்தாச்சு. என்ன வரும் ஆன்சர் அப்ப? What's your opinion? What's your suggestion? So the next module போனோம், quick answers.
Sir, option C is wrong.
Option C? It
Incorrect.
gives information on transformation rate. Okay, good. So that is a correct one. So if possible, you can find some of the question paper related to materials. You can find some question. I just made some questions from 2021 and 2020. Similarly, you can start to prepare and more questions. Okay, interact with your faculty, or I'm ready to answer you. Okay, so this is the first model I just planned regarding the phase diagram. Okay, so next module, that is a next content regarding the heat treatment process. Okay, so it's very simple and very easy to understand. So with your permission, I can go for the next module. One second. So anyone please confirm the slide is completely shared, so it's visible to all. Anyone from student side?
Yes, sir.
Okay, fine. So next module is concept regarding the heat treatment. You are all familiar, but this concept are much easy to understand and very interesting, and application for a metallurgy is very lot of demands. Okay, so when we quickly move to the introduction part, what is mean by heat treatment? So it is it's nothing but you have to improve the mechanical properties of the material. Okay, so the first thing is you have to relieve the internal stress. Internal stress means the stress are formed after welding or any casting formation or forging process. Okay, so grinding operations. So any operation is performed, the surface will have some stress. Okay, so the particular internal stress are relieved, the internal stress, by means of heat treatment process. So the ultimate target is to improve the hardness, mechanical property. That is the main thing. So this is the thing I just suggested. The main purpose is change the mechanical property. Okay, as a result, it is more serviceable, safe for definite purpose. Okay, at the end, after heat treatment, the metal is more harder and stronger. That is a real advantages after completing the heat treatment process. Okay, so heat treatment is nothing but it is an operation involving heating and cooling of the material in the solid state. Okay, so heat treatment is applicable only for solid based material only. Okay, so the thing is you can modify the mechanical property, especially hardness, strength, where these properties are improved or enhanced by means of heat treatment process. Good application. all the gear components, shaft, bolt and nuts are come to heat treatment process only. Okay, so wherever we have to look for high temperature application, definitely the components are heat treatment. Okay, so nowadays we have seen some TMT bar. This is mostly used for construction application, right? Agni TMT. So there is a many supplies. Okay, so the TMT stands for thermomechanically treated steel. So it's all come under heat treatment process only. Okay, fine. So what is the purpose? I already pointed that you can improve the mechanical property, especially ductility will be increased to relieve or to improve the internal stress. Grain size refinement. Ultimately, the structure will be modified based upon your selecting temperature. So once if it is having more than 727 degrees centigrade, the structural modification will happen. The grain size are modified. Is it right? So as a result, increase of strength and hardness will be improved. And last, improvement in machinability and toughness is also increased with the process of heat treatment. So any mechanical property modification, we have to go for heat treatment process. Ultimately, hardness, strength, wear. Okay. So what are the stages are involved for the heat treatment process? So normally the furnace is one of the equipment used for heat treatment process. Is it right? So it is a based upon the ceramic bricks will be used. So this has to capable to withstand the temperature from 750 to 1200. So based upon the purpose, you have to set the furnace. Okay, so normally in our college we have to use some muffled furnace. Is it right? So 850 or 900 below that particular temperature, we have utilized this kind of furnace. So what is the three stages involved in the heat treatment is heating, holding and cooling. It's very, very essential. So heating means how much temperature you're going to maintain, okay, in the furnace, whether you're going to fix 750 or 900. That is the heating temperature set for the different material. Then how long you're going to hold the material, whether you're going to hold the material for 3 hours or 6 hours based upon your requirement and application. So the first stage will be heating, second stage will be holding. So how long you're going to hold your material. So this is a stage where the microstructure modification will be happened. Okay, so based upon the time only the structure modification will be modified. And last one, what type of cooling or quenching will be used. So this is one of the major process involved for the modification of the mechanical property. Suppose if you done rapid cooling, suddenly you cool பண்ணீங்கன்னா hardness will be increased drastically. Drastically suddenly increase ஆகும். அதையுமே நம்ம வந்து பார்க்கலாம் by means of John Dean quench apparatus. It's practically proved that. So air cooling பண்ணலாம், furnaceல நீங்க cool பண்ணலாம், இல்ல rapid cool பண்ணலாம். So based upon the type of quenching, the classification will be modified. Suppose ஒரு சாம்பிளை ஹீட் பண்ணிட்டு 2 to 3 hours ஹோல்ட் பண்ணிட்டு ஃபர்னஸ்லேயே கூல் பண்ணினா அதுக்கு பேர் அனிலிங் ப்ராசஸ். வெரி சிம்பிள். Annealing is a process where the samples are allowed to cool inside the furnace only. It is called annealing process, but it take more time. Time ரொம்ப அதிகமாகும். But ultimately என்ன ப்ராப்பர்ட்டி இன்க்ரீஸ் ஆகும் பார்த்தீங்கன்னா ductile property will be increased. Softness and ductile will be increased. In normalizing process, we have to keep the sample out. That is open atmosphere cool பண்ணினா அது பேர் normalizing process. 10 to 15 minutes samples வந்து cool ஆயிடும். But அதுமே உங்களுக்கு வந்து properties, especially the toughness, hardness will be increased. Okay. Second, you have to make some rapid cooling process. சடனா தண்ணியில எடுத்து போட்டு நீங்க என்ன பண்ணலாம், டிப் பண்ணி எடுத்தீங்கனாலும் உங்களுக்கு hardness is increase ஆகும். Okay. Sometimes they have to use some different oils, animals oils, fatty oils. So a lot of natural based oils are also available. Okay. So suddenly நீங்க வந்து oils டிப் பண்ணி எடுத்தீங்கனாலும் உங்களுக்கு property vary. So what type of quenching is going to adapt? It will reflect the properties of your particular material. So this is the three important stage involved in the heat treatment. Once again, I will suggest stage 1 will be heating process, stage 2 holding process, stage 3 cooling. The other name will be quenching process. Okay. So this is the factors involved. So now you look at some of the samples. This is the transmission gears which are used for heat treatment. You can see the furnace. Okay, so what will happen if you done annealing or hardening? Hardening in the sense sudden quenching process. So already I suggested annealing is a furnace cooling process. You can take in furnace cooling, what will happen? The softness will be increased, but strong will be very less. More ductile property will be achieved. Internal stresses are decreased or reduced only less amount. And last one, less distortion or cracking. Less distortion means failures or cracking will be very less by means of annealing process. Slow cooling na annealing process தான் நம்ம பண்ண முடியும். Okay. Process or oil quenching or water quenching suddenly cool பண்ணீங்கன்னா ultimately we can increase the hardness. That is, hardness will be very high and the material become more stronger. So when you followed the air cooling process, oil quenching or water quenching, ultimately we can improve the hardness and the materials become more stronger. Then as a result, the materials are more brittle, structure will be modified. So ductile means it will show some deformation, but when will happen from ductile to brittle, ultimately the material will be failed without showing any deformation. So this is the result of oil or water quenching process, and more internal stresses are oil or water quenching process. The last one is the more okay. So what type of perimeter furnace to industrial wise. So based upon your requirement, you can select what type of furnace we needed. Okay. So most of the metal matrix composite investigation, they have to prefer variety of furnace. Is it right? So we quickly move to the concept of annealing process. Okay. So I don't want to take much time because we are already 12:18. I just have some slide regarding the MCQ. Okay. So what is meant by annealing? So annealing is nothing but it's a heat treatment in which material are exposed to an elevated temperature for extended time period and then slow cooling process. So annealing is a heat treatment process. The samples are heated in a furnace and holding for a particular time, and the sample should be allowed to cool inside the furnace only. So cooling process should be carried out inside the furnace only. It is called annealing process. So what is the purpose of annealing, or what are the things we have to achieve is you can able to relieve the internal stress. You can increase the softness, ductile and toughness. These are the property can be achieved by means of annealing process, and produce a specific microstructure modification is possible because most of the grains modification will be happened by means of slow cooling process only. So that's why we have to achieve more ductile property. Is it right? So these are the particular information regarding the annealing process. So please keep in mind when you heard about the term annealing is slow cooling process, the samples are cooled inside the furnace only. The important mechanical properties of toughness, ductile and softness will be improved or increased. Okay. So how we have classified so this already we discussed. How we classify the annealing process? We have four important classifications made on the annealing process. The first one will be full annealing process. Second one, process annealing. Third one, stress relief annealing. Last one, periodizing annealing. These are the major types of annealing involved. Okay. So in all the four cases, we have to fix the temperature. Based upon the setting temperature only, the process will be changed. In full annealing process only, we have to maintain the temperature of above 750. The remaining process are all less temperature only. Okay. So anyway, I will show the picture. You can understand what is the full annealing means. It is the sample we have to make the temperature of above 750 degree. The main particular objective of full annealing process is to make the metal soft and to refine its crystalline structure and to relieve or to remove the internal stresses. This is a major objective of the full annealing process. Full annealing process பண்ணி என்ன அப்படின்னா softness increase பண்ணி அதோட crystalline structure hold பண்ண போறோம். To refine means to gain. New grains should be developed. That is called refine. And last one to relieve or to remove the internal stress. இந்த internal stress என்ன சார் கேட்டீங்கன்னா ஒரு மெட்டீரியலை வந்து நீங்க ஃபேப்ரிகேஷன் பண்றப்ப எக்ஸாம்பிள் காஸ்டிங் பண்ணினா மேல பார்த்து உங்களுக்கு தெரியும் சர்ஃபேஸ் வந்து டிஃப்ரெண்ட் ரேஞ்சஸ்ல இருக்கும். ஒரு சில இது அன்இவனா இருக்கும், சில இடத்துல பார்த்தீங்கன்னா ஒரு பின் ஹோல்ஸ் மாதிரி ட்ராப்ஸஸாக இருக்கும். ஸோ அதெல்லாம் நீங்கள் என்ன பண்ணலாம், ரிமூவ் பண்ணலாம். சப்போஸ் அந்த மெட்டீரியல் வந்து நீங்கள் மெஷினிங் பண்ணீங்கன்னா ஒரு என்ன சர்ஃபேஸ் வந்து ஸ்மூத்தாக இருக்காது, சில ஏரியாஸ்லாம் வந்து டிஃப்ரெண்ட்டாக இருக்கும். அதே அந்த மெட்டீரியல் கிரைண்ட் பண்ணியிருப்பாங்க, வெல்டிங் பண்ணியிருப்பாங்க. ஸோ அந்த மாரி மெட்டீரியல்ஸ்லாம் நீங்கள் என்ன பண்ணலாம்னா அதோட ஸ்ட்ரெஸ்ஸை ரிமூவ் பண்ணணும், அந்த சர்ஃபேஸை மாடிஃபை பண்ணணும் நீங்கன்னா அனிலிங் ப்ராசஸ் தான் நீங்கள் பண்ணிடணும். இப்போ எக்ஸாம்பிள் அந்த கீர் எடுத்துங்க, அதோட டீத் ப்ரொஃபைல்ஸ்லாம் பார்த்தீங்கன்னா உங்களுக்கு வந்து டிஃப்ரெண்ட்டாக இருக்கும், டிஃப்ரெண்ட் ஓரியன்டேஷன்ஸாக இருக்கும். ஸோ அதோட மாடிஃபிகேஷன்ஸ் நீங்கள் பண்ணணும் அப்படின்னா டெஃபினெட்லி யூ கேன் கோ ஃபார் ஹீட் ட்ரீட்மெண்ட் ப்ராசஸ். திஸ் இஸ் ஒன் ஆஃப் தி குட் எக்ஸாம்பிள். அதே மாதிரி ஷாஃப்ட், கண்டிப்பாக ஷாஃப்ட் மெட்டீரியல் நீங்கள் எடுத்தீங்க அப்படின்னா மெஷினிங் ஆப்ரேஷன் இல்லாமல் இருக்கு, டர்னிங் ஆப்ரேஷன்ஸோ மெஷினிங் ஆப்ரேஷனும் இல்லாமல் இருக்கு. அப்போ டிஃப்ரெண்ட் ஆப்ரேஷன்ஸ் பண்றப்ப அந்த சர்ஃபேஸ் எப்படி இருக்கும் அப்படின்னு பார்த்தீங்கன்னா there is a formation of more internal or residual stresses because this stress will act as a more failure, chances for failure. இதை நம்ம வந்து டிசைன் ஆஃப் மிஷின் நம்மள படிச்சிருப்போம், ஸ்ட்ரெஸ் கான்சென்ட்ரேஷன் ஃபேக்டர் அப்படின்னு படிச்சிருப்போம். ஸோ these are the various problems may be occurred. Okay, so this is the particular where we have to prefer for heat treatment process. Is it right? So the main objective is to make the metal soft, to refine its crystalline structure and to remove the internal stresses. Okay, so what are the materials are most adapted for this full annealing process? You can take steel casting or steel ingots. Most of the steels are come under this category, full annealing process. Okay, so this is the information where I just want to share. In full annealing process you can select the hypo Eutectoid steel. Hypo means the sample should be less than 0.8% of carbon. Okay, so it should be heated 30 to 60 degree above upper critical temperature in the ranges of 727 degree to 910 degree centigrade. So this is the maximum temperature utilized for the full annealing process. I will show the picture. So what is the main objective? You have to improve the surface. So the resulting structures are porous Perlite with excess Ferrite. Okay, so we are much familiar with the term Perlite and Ferrite. Okay, so I don't want to take the thing, I just projected where we have to done the full annealing process. So as point of view, I just suggested I am taking the full annealing process of hypo Eutectoid steel. So less than 0.7% of carbon I selected. Here you can see the temperature. This is 727 degree and 30 to 60. So you can take upper critical temperature. So what I suggested, I can heat my sample at 850 degree for 3 hours duration. Is it right? So what will happen? It's a full annealing process. Full means above 727 degree. Okay, so this is the point where I have to make the samples to be heated. What will happen? What will happen? The grains structure will be modified because we have to go for upper critical temperature. So new grains are chance to develop. Is it right? Okay, so this is the point where we have to find. Then the sample is allowed to cool. Then all the austenite, can you see the face? All the austenite are changed or modified or transformed to Perlite. Perlite அப்படினால என்னது? It is a formation or mixture of ferrite and cementite. அப்ப இந்த மெட்டீரியல்ஸ் என்ன சார் ஆகும் உங்களுக்கு? This material ferrite are more softness in nature. Is it right? இது நம்ம எங்க படிச்சோம்? மைக்ரோ கான்ஸ்டிட்யூட் ஆஃப் மெட்டீரியல்ஸ் நம்ம படிச்சிட்டோம். ஃபெரைட்னாலே சாஃப்டான மெட்டீரியல்னு சொல்லிட்டு. Is it right? So this is the quite informations we have collected by means of full annealing process. So the same concept you can apply for hyper eutectors. What will happen? In hyper eutector steel, you can make the percentage of carbon from above 0.8 percentage. So what is the temperature we have to fix is 727 or 30 degree. 750 degree samples and heat pannalam. That is called full annealing temperature. This is very important. What type of temperature or what temperature we have to select for hypo and hyper. So hypo means less than 0.8. We have to go for maximum temperature. But here only 750 is sufficient for the hyper eutectoid steel. So more than 1.16 percentage. Right? 7.8 மேல இருக்கலாம் 1.2% நீங்க select பண்ணிக்கலாம். ஓகேவா? So what will happen? Austenite is going to change it into Peritectic. Is it right? So in process annealing, process means after completion of the casting or forging product, any material, you have to remove the stain hardened metal. Okay, example, steel wires, sheets, low carbon steel materials, plate, okay, channels. You can take many examples. After completion of the casting product, you have to go for process annealing. What we are going to do is you can fix the temperature below 727 degrees temperature. But now 500 to 450, this is the particular temperature we have to go for process annealing. So what will happen? The previously stain hardened metals are removed and to increase the ductile property. Okay, so now you can look at the purpose. In process annealing, the heat treatment is often used to soften and increase the ductility of the previously stain hardened metal. So previously stain hardened metal means after completion of the fabrication process, example casting. Okay, so this is the particular temperature we have to fix for process annealing. So now you can imagine that. So in the operation, in process annealing, we have to take the low temperature. Percentage of carbon is very limited, 0.25 percentage, and I suggested the temperature from 550 to 650. Okay, so what will happen? The softness and ductility will be increased. The main application of process annealings are steel wires, sheet metals, channels. These are the good application for the process annealing. So any casting product you can prefer process annealing operation. Is it right? So now you look at the stress relief annealing. Stress relief annealing means after completion of any grinding process or welding process, okay, we have to go for stress relief annealing. Stress means some okay, fine. So in stress relief annealing, heat treatment process is employed to eliminate the internal stress induced by means of casting, pinching, machining, cold working operation, or welding process. Okay, so these kind of internal stresses has to or we are positioned to remove by means of stress relief annealing process. So here what the thing will be modified is the plastic deformation process such as machining, grinding, non-uniform cooling of metal that was processed at fabricated elevated temperature, phase transformation that is induced upon cooling when parent and product phase have a different density. So these are the major consideration for the stress relief material. Okay, so again what the temperature we have to fix for stress relief annealing is 550 degree to 650 degree centigrade is normally preferred. Okay, so stress relief is also called recovery. Please note down the term. Stress relief is also known as recovery process. Recovery means you can to gain, you can get back. It's a low temperature phenomenon to remove most internal stresses, but little changes in the mechanical property and no drastic change in the microstructure. Very important, because in stress relief process we have to modify any mechanical property. Previous toughness will be increased, but in stress relieving only the surface, that the outer surface of grinding or any other thing will be improved. Okay, no mechanical modification is happened. Please keep in mind that the other name of okay, last one will be recrystallization annealing. So this is very essential, where the microstructural modification will be changed. Okay, so what we have to prefer is above 727 degree temperature, we can say it is a recrystallization temperature. So we can make it's a hard working process. Is it right? So most of the crystallization modified, as a result it will produce or modify the mechanical property. So I will show the temperature. So you can look at some application of the recrystallization. So you can entire steel metals are modified. Is it right? So this is the rectangular beam. Okay. So this heat treatment process, the cold work steel is heated to temperature above recrystallization temperature, and this material has to produce a new structure. We can say it is a form of new grains are developed. So this result helps to increase the properties of ductile strength will be increased. So most of the metals are deformed under hard working condition process or cold working. Is it right? So new shape or new modification of the structure will be happened under recrystallization process. It's very essential, quite interesting. So last one will be periodizing annealing. Periodizing annealing means spherical shapes will be appeared where we have seen in the nodular cast iron. Similar fashion, the microstructure modification will be happen. The spherical shape of structure will be appeared. As a result, the softness and ductile will be increased. Okay, so you can look at the periodization application. So these are the thing. After completing the heat treatment process, you can look at the microstructure. You can find some of the spherical shape of carbon. Is it right? So if you perform this kind of application, ultimately the mechanical properties of softness and ductile will be improved or increased. Okay, so shaft, gears, so essential application. Look at the thing. Toughness, ductile will be improved. Machinability and formability. This is very important. So formability means we can able to change or modify any structure of the material, and to reduce the hardness, strength, and wear resistance. So this periodical heat treatment is more suitable for tool-based material. Okay, so pipes, flanges, machine tools, you can take good application for the periodical annealing process. Okay, so most of the cases more suitable. Is it right? Okay, so you can find some of the applications like shaft and all. Okay, so this image is, we can see the temperature maintained for periodical annealing is below 727 degree only. Okay, so the austenite sample will be modified into ferrite and cementite. You look at the images, you can see at below 720 the sample is heated for 3 hours. The entire austenite, you can see the lamella, the entire structure of is break into spherical cementite in ferrite. So presence of carbon in the form of spherical shape. So these are more suitable for crankshaft based application, pipes, machine tool. Okay, so finally we have a single diagram. It will clear all the temperature correspondingly changes of the process. Okay, in the x-axis we have look at the y percentage of carbon, and y-axis we have temperature. Okay, so what is the temperature we have to maintain for process annealing? 700 to 500. Is it right? What percentage of carbon we have to fix is hypo-eutectoid. So 0.2 percentage of carbon is sufficient for or more suitable for process annealing. Is it right? And periodical annealing, we have to fix the temperature of 700 to 727 degree. Is it right? So the most suitable materials are hypo-eutectoid steel, because its percentage involved is from more than 0.8 to 1.6. So these materials are more suitable for Periodizing annealing process. That's why I prefer medium carbons are more suitable because it having percentage shown 0.5 and all. Okay, is it right? It is one of the quite interesting. And full annealing process, where we have to make full annealing is above 727 degree. Is it right? So this is only one process where we have to make above 750 degree temperature. So you can see the application. It's more suitable for all kind of steel material. Is it right? And normalizing is nothing but it's an open air cooling process. It is adapted to all the any form of material. Is it right? So my suggestion, you have to understand the terminologies used for annealing process: full annealing, process annealing, periodic annealing, recrystallization or stress relief annealing. So it is more suitable for all type of steel based upon your requirement and application. Okay. The thing is softness, ductile, toughness, hardness can be increased. That is a major thing. So normalizing is nothing but the samples are allowed to cool inside the furnace. The entire structure appears in the austenizing form, holding for a particular period of 2 to 3 hours based upon your application. Then the sample should be cooled in air cooled system. That is air quenching process. So it is called normalizing process. So heat treatment to refine the grains, to decrease the average grain size, more uniform size distributions are possible. So the process should be carried out above 55 degree from the eighth line. Eighth line in the sense you can make it as 750 to 850 degree. So normalizing process are more suitable for 850 to 750 to 850 degrees centigrade. Is it right? So what is the thing? Only modification is samples are permitted to cool in the open atmosphere. That is called air cooled system. There is a major difference. So this is the fine Peelite structure will be obtained in the normalizing process. So all the austenite will be transformed to peelite structure. So ultimately we can increase the strength, hardness. Okay. So this is the quite interesting application or microstructural modification for the normalizing process. Is it right? So full annealing versus normalizing. So this is a different story. So we have to understand about the time temperature transformation curve. Triple T diagram வந்து நம்ம இது தெரிஞ்சாதான் இந்த கான்செப்ட் நம்ம போக முடியும். So it is a different content. Okay, so I just want to make much definition in this particular area. So full annealing versus normalizing means full annealing process we have to fix the temperature of 750 to 850. Is it right? So formation of new grains, softness. So normalizing, how the austenite will be modified to martensite. So that is the thing. It will have formed the coarse pearlite, then fine pearlite, bainite, then martensite. Martensites are the more hardness material when compared to other forms of the material. So that is a clear picture. So we can move for the next one. Finally, we look at some microstructural modification from the full annealing process or normalizing. Okay. So here you can see the coarse forms of pearlite, but here normalizing process we can see some of the lamellars are fine and smooth. Okay. So that is a major difference. So based upon the modification of the structure, it will create better mechanical property. Okay. So when we speak about the temperature and cooling process, it will change the microstructure. Okay, so we have to concentrate the parameters or variables of temperature, composition. Okay, that is very, very important. Then what type of cooling mediums you are adapted. So based upon the selection of cooling process or quenching process, it will result your mechanical property. Is it right? So you can find some of the furnace cool, you can see the portion like centrally we have find some of the alpha. Okay, and here it's a closely packed system. You can't having much chorus. Is everything will be finely a smooth appearance. So if we having this kind of structure, ultimately the bonding will be impressed. As a result, strength will be increased and hardness will be increased. So the final thing, what type of cooling medium your adapter are suggested, it will produce the end results. Okay. So already we have suggested. So this is information what mechanical property after cooling process will be increased. Ultimately, I can say the temperature, that is called what type set of temperature we have defined. It will increase the elongation. That is ductile will be increased. Okay. As a result, toughness, that is impact energy. Toughness will be increased. strength will be strength will be increased. So these are the three mechanical property involved for the annealing: impact energy, tensile, yield strength. Okay, elongation. So next, another important heat treatment process, surface hardening process. Here there is no any internal modification, only the external surface should be coated with carbon or nitrogen in order to increase the mechanical property, especially wear resistant hardness. Is it right? So the depth, what type of thickness you are going to maintain, that is depth of coating, whether 0.5 to 2.5. Okay, so that is called depth and slope. So hardening process means nothing but steel will transform to harden the structure on quenching. It is called hardenability. Okay, so the hardness, hardenability of and as depth, distribution of hardness impacted by the how the hardenability tests are conducted with the help of Germany is practically demonstrated how the hardness is improved by rapid cooling process. Okay, so it is one of the very good setup where we can find. So this is the image. I think it a little bit practically you have been done. I think in a second first year itself in your metal testing lab. Is it right? Metal testing or metallurgy lab, you will practically done the experiment. Okay. So what I'm going to do is I'm taking the steel sample. The sample should be allowed to heat for 850 degree for 3 hours duration in the furnace. Okay. So after taking the sample, I just positioned in the Germanian setup. Okay. So this is the holdings frame where I just position my sample, and the bottom I just have some nozzles which helps to spray the water at the surface. Is it right? So only this particular area will be cooled. And you got the point? Only the bottom surface will be cooled, then it will slowly transform to the end. So after conducting the test, I have to check the hardness value where I just done the cooling process. What is the hardness and what is the different from other end? Okay, so practically I just check the hardness by means of Rockwell hardness test. So I take the sample, I just mark from 10 different points. Okay, so gap of 1 centimeter. Okay, you have to maintain some equal distance, so you have to mark some points, check each point having the hardness value. So this is the point where we have done the cooling process. Can you got the point? So this is the point where இந்த பாயிண்ட் என்ன பண்ணிருக்கேன் அப்படின்னா வாட்டர் ஸ்ப்ரே பண்ணப்ப இங்க வந்து ரேபிட் கூலிங் நடந்திருக்கும். கரெக்டா இல்லையா? ஓகே, ஃபாஸ்ட் கூலிங் தான் நடந்திருக்கும். ஸ்லோ இந்த என்ன நான் பண்ணவே இல்லை. அப்ப 50% மட்டும் தானே இருக்கும், ரேபிடா கூல் ஆயிருக்கும். கேன் யூ காட் த பாயிண்ட்? இந்த சர்ஃபேஸ் மட்டும் தான் கூல் ஆயிருக்கும், அந்த சர்ஃபேஸ் வந்து கூல் ஆயிருக்காது. அப்ப எதுல நம்ம ஹார்ட்னஸ் இன்க்ரீஸ் ஆகுதா இல்லைன்றத நம்ம ப்ராக்டிக்கலா டெஸ்ட் பண்ணதுக்கு தான் ஜாம்னியன் apparatus. ஓகே, ஸோ ஸ்டீல் சாம்பிள் எடுத்து ஹீட் பண்ணிட்டேன், அந்த பர்டிகுலர் போர்ஷன் மட்டும் வாட்டர்ல கூல் பண்ணிட்டு I can check the hardness value. So I can locate a different distance, mark பண்ணிட்டு I can check the hardness. So first point I'm getting 58 is my Rockwell hardness C scale. Okay, RC means Rockwell number, C scale பார்த்தா அப்படின்னா 58. Second location almost getting 58, third 50, 60. So up to this one I can find maximum hardness because this is a particular area region where we have done the sudden cooling process. Next, the 50% material where we have some open cooling. Is it right? It will show the hardness of 40, 30 like that. So this graph, it will clearly indicated when sudden cooling process helps to increase the hardness value. So that is called hardness. So it's practically proved that if your material is started, it will be heated, and if you've done rapid cooling process, it systematically increase the hardness value. அதை கண்டுபிடிச்சது யாருன்னு பார்த்தீங்கன்னா Jomnian Winch apparatus. Is it right? So this is practically he proved. So what are the applications for many steel materials? Okay, shaft, bearings, it's all come under rapid cooling process. You can take many applications. So next concept I want to touch is case hardening process or surface hardening process. So here what we are going to do is the outer surface should be coated. Outer surface should be coated with carbon and nitrogen in order to increase the mechanical property. So where we have to go for this process is especially gear based, camshaft, universal joints, walls material, couplings, flanges. So we have quite bolts and nuts. So many applications are like, okay, engine cylinders, pistons, this all what wherever we have to go for high temperature application, definitely we have to done the surface hardening process. Is it right? So what the thing is, the inside or core should be soft, the outer should be hard, because we are going to modify the outer surface by means of diffusion or depositing of carbon and nitrogen element or material. Is it right? So what will happen? Ultimately we can improve the mechanical properties of hardness will be increased. Is it right? So what are the techniques or methods available for surface heat treatment process? So I can say the first one with diffusion. Diffusion means you are going to deposit carbon and nitrogen. The term is called carburizing process, nitrating process, cyaniding, carbonating. Other method is called thermal process or thermal methods. It's one will be flame hardening and second will be induction hardening. Flame means thermal heat treatment by means of oxygen acetylene. Induction means through help of current. Okay, so this is quite interesting. Almost you are familiar with the process. Is it right? So I don't take much time. We quickly move for the carburizing process. Here the carbon atoms or carbon should be deposited on the outer surface of the low carbon steel. Low carbon steel means the composition of carbon should be less than 0.025%. Is it right? So I'm taking the steel of 0.1 to 0.2% of carbon I'm selected. Okay, so what are the materials involved for the pack carburizing process? So the thing is, the rich carbon material of charcoal is selected, and we have to have some chemical material like sodium carbonate or barium carbonate. These materials are called as energizer because this material is used to accelerate to or liberate more carbon from the charcoal material. Is it right? So the term is called energizer. So the low carbon steel should be heated 900 to 950 degree in a furnace for 6 hours. Is it right? So 900 வந்து 950 degree வரைக்கும் நம்ம என்ன பண்ணிட்டோம், ஃபிக்ஸ் பண்ணிட்டு 6 hours duration என்ன பண்ண போறோம், furnaceல heat பண்றோம். Okay, I will show the picture. So this is a practically how the pack carburizing process are processed. Is it right? So this is our steel sample. You can take it is a low carbon steel, and this is a fully mixed with the charcoal material, and the energizer of sodium carbonate and barium carbonate is used. So what will happen? This energizer helps to liberate more carbon from the charcoal. So the carbon should be deposited on the steel material. So this is a furnace where we have to maintain 952 degrees centigrade for 6 hours duration. So all the carbon should be deposited on the steel material. So now you can look at the depth of coating. How much depth you have increased. So 0.5. So what time duration is required? So example 0, 10, 20, 30, 40. These are called duration, time of treatment. This is the depth. Suppose I want to develop a 1 mm thickness. So what duration I can prefer? Only 6 hours is sufficient. Okay, and the corresponding temperature will be 900. Suppose I want to coat 2.5 mm thick. What temperature I have to suggest is 950 degree, but the duration will be 16 hours. Okay, so based upon the thickness, your time will be increased. That is a very good information we have to collect from the pack carburizing process. So your requirement, your application, you can select the depth of cases. Is it right? So this is the chemical process involved. So it's not much time. Okay, so I projected the materials name will be barium carbonate or sodium carbonate or the energizer material. Is it right? So the finally you can look at the carbon monoxide and Fe. So finally iron plus carbon. This is the major thing. The surface will be coated, iron will be coated by carbon. So it will give more hardness value when compared to other process. So quickly move to the next one will be nitrating process. The name itself, we are going to deposit the nitrogen on the outer surface of the steel component. Is it right? So nitrogen and then என்ன பண்ண போறீங்க outer surface of the steel componentல கோட் பண்ண போறோம். எவ்வளவு சார் 0.5 to 2 mm based upon your requirement நீங்க கோட் பண்ணிக்கலாம். So இது எப்படி சார் பண்ணலாம்னு கேட்டீங்க அப்படின்னா this is the picture where we have to select ammonia gas. Okay, so ammonia NH3. So here this is a wall and we can check the pressure. You can able to control the thing, and this is a furnace where we have to maintain. So what is the temperature? Now you look at the temperature involved for nitrating process is you are selecting the steel sample 500 degree for 40 to 100 hours. So previously we have seen about the temperature of 750 and above. Is it right? But here in nitrating process we have to fix the temperature of 500 degrees centigrade, but the duration is 40 to 100 hours. ரொம்ப அதிக நேரம் டைம் சரியா? So ammonia, hydrogen, nitrogen. Is it right? Okay. Now we come to the picture. So this is a furnace where we have sample is positioned. This is considered this is a steel sample. The sample should be allowed to heat for 40 to 100 hours at the temperature of 500 degree. So here the ammonia gas. So this is the gas will be involved. So most of the nitrogen N will be deposited on the surface, outer surface of the material, right? This in hydrogen will be exhausted or collected from the gas outlet. So where we have to apply this nitrating process? These processes are more suitable for aircraft engine parts, especially aero engine cylinders, aero crankshaft, bearings, valves, bushing. So these are the most of the aero turbine blades is also come under nitrating process. So nitrogen should be deposited. So this is a quite interesting application. So most of the high temperature application we have to select nitrating process. Is it right? So the another important will be cyaniding. Cyaniding is nothing but it is a liquid carburizing process. So you can see the images. So where the steel sample after heat treatment will be dipped into the chemical solution. So it's nothing but cyanide path. It is contained of nitrogen as well as carbon. Okay. So what is the molten metal used for cyaniding process? Sodium cyanide and sodium carbonate. So both the thing, and for the steel metal should be heated at 950 degree centigrade. So during this treatment, both carbon and nitrogen should be deposited on the surface of the steel material. Okay. So these are the application where I can prefer the cyaniding process. Most of the brakes, cams, okay, springs, shaft, these are the varieties of application for applicable for cyaniding process. Is it right? And the depth of case and the coating as well, it can be 0.1 mm to 0.5 mm. Okay, so these are the possible for cyaniding process. The only advantage is it will take less time when compared to pack carburizing and nitrating. Cyaniding is a short span of time we can complete, or we can coat the carbon and nitrogen. Okay. So this is the last process, carbonitrating. Both carbon and nitrogen should be deposited. So here we have to use two gases. One will be ammonia, it will be liberate nitrogen. And another preheat purpose I have to use some propane gases. Is it right? So you take the picture. So this is the conveyor. I just positioned my bolt nut is a good example. And this is the preheat. I have to use some natural gas. And this is the carbonitrating zone where carburizing gases like propane and ammonia gas are mixed together. Okay. So this is called carburizing mixture will be used. And last one will be quenching process. So preheat means we have to 300 to 400 the sample should be allowed to heat. Okay, and here in the carburizing zone the temperature will be around 550 degree centigrade, and the normally 2 to 10 hours will be required to complete the process. Okay, so here the case depth will be 0.5 mm is possible noted. Is it right? So where we have to suitable application like geese, nuts and bolts. So these are the quite interesting application from the nitrating process. The only thing is carburizing gas of propane and ammonia gas of NH3 will be used. Okay, so rest of things are very common to. So you can practically see how the nitrating process are carried out in industry. Now you can look at the temperatures above 850 degree. It's like a reddish color. In the sense, modification will be happen. So this helps to coat the material perfectly in order to achieve the hardness and remaining properties. Is it right? So these are the various processes we have involved. For carburizing, the suitable temperature will be 900. Carbon element should be deposited. Application wise, steels, alloy steels, mild steels are the major applications, and hardness will be increased. Okay, so again carbonating, we have to mix the temperatures of 800 to 850. So most of the applications come under alloy based steels only. Okay, so nitrating, so nitrogen should be deposited, and most of the suitable applications of aerospace engine component, engine cylinders. Okay, so the temperature will be 500 to 550. Last case, that is called nitrating process. So carbon and nitrogen should be deposited from ammonia gas and propane gas or methane gas. Okay, so different application or your requirement, you have to select the process. And last one will be selective surface hardening by means of thermal process or induction hardening. So in thermal we have to use okay, so in thermal process we have to use oxygen and acetylene torch. Is it right? So this is more suitable for high carbon, that is low carbon steel. Example 0.4% of carbon steel should be applicable for the flame hardening process. Okay, I will show the picture, you can understand. Now you can look at the diagram. So where we have to adapt this process is example surface teeth of gear material, wheels, shaft, mill rolls, cams, spindles, machine tool. So quite interesting of many application. Okay, so now this is your sample. You can consider this is a shaft. So this is a torch where we have to mix with the oxygen and acetylene. So the flame will be produced. Parallelly, we have to connect some nozzles. Through the nozzle we have to pass the jet of water. So parallelly, after completing the flame hardening, we have to done the rapid cooling. Systematically we have to done the cooling process. So this is by means of thermally we have to improve the hardness of the material. Is it right? So this is also helps to increase the mechanical property, especially hardness, and that will be increased. Okay, so induction hardening is, but in thermal it will take much time and uniformity will be, it's a drawback. Okay, so uniform hardening process is very quite tough. Is it right? And the time consumption is very high. So this is a major drawback. But whereas in the case of induction hardening, the time consumption is very less. By means of electric current, we have to make the materials more hardness. So this is a picture where we have to see through the electric current. It has to fix some frequency ranges of 300 Hz, depth of 3 to 6 mm for 9600 hertz for, that is a frequency suitable for 3 to 2 to 3 mm thickness. Okay, so what are the requirement we have to fix the current? Okay, so this is the cases where we have to done the cooling process. Parallelly we have setup of quenching medium, so water should be allowed to cool the sample. Okay, so that's why we have provide the provision. So practically they have a lot of applications about regarding the induction hardening process. The only thing is time consumption is very less and uniformity of hardening is possible. So that is quite interesting. And the last thing, many application like nowadays they're using some laser based process also. Okay, so where the suitable application of induction hardening, you can take the tool drives crankshaft, engine cylinders, liner, machine tool, pumps. Okay, so some quite interesting application of both thermal as well as induction hardening process. Okay, but here we don't have any deposition. Only thing is surface will be modified. That's all. So previously we have done some carbon and nitrogen, but here we don't have any coating material. Is it right? Only thing the surface will be modified. So up to this, I will wind up the session. So before concluding that, I will just have some questions. I just want to share you. So just a second. So this is the last thing I want to discuss with you. So I just want more participation from the student side. So I will have some questions to you, MCQ practice. So can anyone answer the question? What is the brass alloy of copper and zinc? Example, what type of solid solution is it? I expect from student side, please respond. What is the combination of copper and zinc? What type of solution is it? தப்பான பரவாயில்ல கொஞ்சம் பசங்க இன்டராக்ட் பண்ணுங்க ப்ளீஸ். What type of solid solution is it? Substitutional, interstitial, intermetallic, all the above. Which one is correct?
Sir, the module is not visible, sir.
Not visible. Okay. Thank you. Stop sharing. Now you can check whether the slide is shared.
Yes, sir.
Okay, fine. So can you find the answer? Which one is correct? Brass is alloy of copper and zinc is example for substitutional, interstitial or intermetallic. Which one is correct? Or all the above? From the beginning itself, I just have the example. Copper is a solvent having more percentage, 64%. Zinc is a solute having 36%. So when combining copper and zinc, what it is whether it is a substitutional or interstitial or intermetallic. Which one is correct? கிளியரா அப்சர்வ் பண்ணிருந்தீங்கன்னா ஆன்சர் நீங்க பண்ணிடுவீங்க. நான் சொல்லி கொடுத்தேன் ரீப்ளேஸ்மெண்ட் அப்படின்னு ஒரு வார்த்தை யூஸ் பண்ணேன். இஸ் இட் ரைட்? I use the term as replacement of solvent by adding solute அப்படின்னு சொன்னேன். What answer? Okay, so already we are running out of time. I can say it is come under substitutional solid solution. Okay, copper element should be replaced by zinc element. Is it right? So the first answer will be substitutional solid solution. Try the second one. In process annealing, the hypo-eutectoid steel is, which one is correct? Any quick answers from student side? In process annealing, the hypo-eutectoid steel is?
Sir, change the slide, sir.
Change the slide.
Sir, not visible the slide.
Which this one is visible? First one. In process annealing, the slide is visible to all. Please kindly check.
Now it is visible, sir.
Visible? Okay,
Yes, sir.
I will make it as full screen, that is slideshow. Now you can look at the question. In process annealing, the hypo-eutectoid steel is, which one is correct? The single picture, it will have different information. I just have some different color I marked. Pink color, blue color, green color. In process annealing, the hypo-eutectoid steel is, which one is correct? Upper critical temperature means 727 degree. Which one is correct? Okay, answer is D.
D, sir.
Answer is
D.
D. Excellent. Your name?
Gokul, sir.
Okay, good. Only full annealing process only we have to maintain the temperature of above 750. So remaining and all, it should be below lower critical temperature. Example 727 K தான் எல்லாமே இருக்கும். Example 300, 400 or 550. So these are the range. So in process annealing, the hypo-eutectoid steel should be heated below or close to lower critical temperature. Very good. So can you find the third one? The slide is visible. First of all, kindly check. Make sure that
Second question is visible, sir, but third question is not visible.
any network issue, I think.
Yes,
So
sir. Now
now,
it is visible.
okay, so I don't want to go for a slideshow. I just fix the screen as it is. Normalizing of steel is done to what? Normalizing of steel is done to which one is correct? Whether we have to refine the grain structure, remove strains, remove dislocation, or all the above. Which one is correct? Normalizing. Normalizing means the sample should be heated and allowed to cool by means of air cooling system. Okay. So what the objective, what the answer will be? Any guess or any try from student side? Gokul, Sanjay first பேசணும் அப்புறம் சஞ்சய் ரெஸ்பாண்ட் பண்ணவே மாட்டானே. Sanjay, Harish,
Sir, all the above.
excellent. All the above. நெட்ல சர்ச் பண்ணிருக்கியா?
Less.
Okay, fine. Okay, so is done by means of all the thing. You can get structure will be modified. You can chance to remove the strains, and you can possible to remove the dislocation. Dislocation means some kind of failures like a delamination. Okay, cracks and all. Some fracture also is possible. So fourth one, steel contains what? What percentage of iron? Steel contains what percentage of iron? Okay, so don't want to take much time. 50% and more iron. So remaining are the form of carbon and some alloys. Is it right? So the correct answer will be B, 50% and more carbon. Last question. Last question only. Okay. So can you find the correct one? When steel containing less than 0.8% of carbon, when steel containing less than 0.8% of carbon is cooled slowly from temperature above or within the critical range, it consists of what? We have familiarly used the term. Which one is correct? Repeatedly I used it. And steel containing less than 0.8% of carbon is cooled slowly, temperature above or within the critical range. It consists of what? So all the austenite are changed into அப்படின்னு சொல்லி கொடுத்தேன். என்னது? All the austenites are changed into. Any guess or any good answer from student side? What is the correct one? When steel containing less than 0.8% of carbon is cooled slowly.
So ferrite and pyrite.
Excellent. So the answer will be C, is in the formation of ferrite and pearlite. Okay. So thank you all for your participation and your response. Okay. So Okay, so thank you for patiently absorbing my presentation and for better participation. Okay, so anything you want to clarify or any other doubt, you can contact with this email ID. So thiago@smec@gmail.com, and you can freely contact with the WhatsApp number I just mentioned as 9092608765. Okay, so if you want any other further material, I can share, and I am ready to handle the session also in future. Okay. So any doubt regarding from student side or anything you want to discuss? So any clarification or any other thing, any aspects? Okay. So no questions. Any question illiyappa from student side? Okay. So thank you. I extend my sincere thanks to the participant and the faculty members for providing opportunity to share my experience regarding engineering material. And I once again I my best wishes for the Hindustan College of Mechanical Engineering student for preparing your GATE examination. May all the best and my sincere wishes to all. Thank you. So with this, I will wind up the session. Thank you all. Okay.
Thank you, sir.